tasks. Of course, classification. This is where we are exaggerating it, and this is very dangerous, and it's becoming one-sided, and everybody is doing classification. Since 2 years, I'm intentionally avoiding classification because I don't want to get biased with the mainstream. Everybody is doing classification because it's straightforward. You give me the data, you give me the label, I train it, I generate it, I give it to you. There you go. I can go home, which is okay for many cases, but not generally. Of course, we do estimation. You estimate, usually we estimate the probability of something, which could be also prediction. So are you predicting what happens when I get to the curve, what would my robot see? Or what happens tomorrow on the stock market? Or if I give this chemotherapy to the patient, will the patient survive or not? So can you predict that? So you can easily imagine many, many useful applications for prediction, which is we estimate the probability of an event based on the data from the past. Of course, search. This is my domain. I love it because this is an absolute minority in the mainstream. Not many people are doing search because search is tough. And you cannot show 99% accuracy for search easily. You have to spend years of development on it. So searching for something in a large archive, searching for patterns that we have never seen, is impossible for a human operator to see those patterns. Can we do that? That would be something, an exciting aspect of AI. To find things that we cannot see as humans. I want to see AI doing that for us. And of course, optimization. The entire history of human evolution and evolution of plants and animals on this planet is about optimization. How can it be intelligence without optimization? We have to optimize things. So if I come up with something, can I optimize it in some way? And then I can deploy it as a solution. And of course, inference. This is not an exhaustive list, so just the most important one. How can you infer knowledge based on the knowledge that you have from the past? New knowledge. How can you infer new knowledge? Give you a simple example that we will come back to it. So you say, if the student work hard, the student will be successful. And then you see that the student is not working very hard. According to the rule of logic, you cannot make any statement. So you have only the statement that says, if the student works very hard, the student will be successful. If you observe that the student works hard, just hard, not very hard, you cannot make any, computers cannot make any statements about that. So inferring knowledge from previous observations is subject to uncertainty and vagueness. This is still a big part of AI. People are telling stories to the young people, now we can do everything with deep networks. No, we can't. I love deep networks. I work with deep networks. My career started with artificial neural networks, but it's just 20% of the problems. 80% we need all that, everything else. So don't customize too much, because especially you're young. I can customize. I will retire in some years. So I can focus on search and say, I will only use this one. I don't have anything to risk. You have to keep your options open. So you have to be a generalist at the moment. So you have to have the overview, the broad overview, what is possible and what is not. So I'm making the argument that all this is approximation. So AI is about approximation. And what is approximation? Approximation is that you have a black box. Some x goes in, some y comes out. So there is an f of x inside this, and x is a vector and is usually multidimensional, is usually hyperdimensional.